All right, now we are going to be writing up a confidence interval, and it's going to be similar to what we did with hypothesis tests. So the four-step process is fairly similar. Now, for our first step, we just have to define what parameter we're looking for, and then we do the conditions, carry out the calculations, and interpret that confidence interval in the context of the problem. So let's take a look at this one. This is kind of a weird problem. I'm going to do my best with it. They're not all this weird. But we've already done this one. It compared the women who vote for Obama and the men who vote for Romney in the 2012 election in Oregon. So what we want to do is we want to first talk about what parameter we're looking for. So we are looking for the difference in proportions between Oregon women who voted for Obama and men who voted for Romney. So we're not just looking for our sample, we want it to be of all Oregon women and all Oregon men. So that is our parameter. That's the thing we're looking for. Now after we have that, now we have to look at the conditions. Now the conditions are the same as um, as what we've done before. It says that they took a random sample of the voters. So data come from a random sample. We need to check normality. So for normality, we can see that these numbers are quite high. So 1642 is greater than 10. If you subtract 1642 and 3017, that's 1375. That's greater than 10. I should probably put a comma in there. The other sample had 1176, which is far greater than 10. And then 2271 minus that is 1095. That's greater than 10. Since all those are high, we can use a normal distribution. And then we should look for independence. So since these all come from a larger sample and we're taking a random sample, we have to check the 10%. So there are a lot more than the number of votes. So that's 52,880 voters in Oregon. All right, so we have that one figured out. So now we just have to do the calculations, which we already did on a previous page. So since we did this on the previous page, I just copied and pasted it over here so you can see what we would like in there. And so now we just have to interpret. We say we are, is this 95% confident or 90% confident? So we'd say we are 90% confident that the true, or, and now this one we go back to this, that the true difference in proportions, we can even copy and paste this if you're on a computer, which you won't be ever, but or in this class, that's the difference in proportions between Oregon women who voted for Romney and men who voted for Romney. And then you say is between 0.003 and 0.049. So that is our that's how we interpret. We just say we're 90% confident. We talk about the parameter and say it's between those two values. All right, we got one more for you. This is another one that we've done before. It's about researchers studying vitamin C content so they can be destroyed, that could be destroyed in the result of storage and shipment of a commodity to its final destination. The researchers specifically marked a collection of bags at the factory and took a sample of each of these to determine the vitamin C content. 5 months later in Haiti, they found the specially marked bags and took samples. The data consisted of two vitamin C measurements in each bag, one at the time of production and one uh, at the factory, and then 5 months later in Haiti. Here's the data. So we have all the data. All right, so we have the data, and uh, in the first, uh, in the chapter, a few chapters ago, we found that there was a significant difference here, but now we want to figure out how big of a difference it is. So where is the difference located at? So since these values are connected, this is just a one sample t-test as on the difference of the values. So what we want to do is first talk about the parameter. So our parameter is we want to find the difference in all uh, or maybe the amount of bytes in C destroyed in all of this commodity. It didn't say exactly what it is, so we want to figure out how much was destroyed in all of it. We have the sample, we know what our sample says, but we want to know, estimate what it would be for all of it. So the next step is to do the conditions. This is a one sample t. So first off, we see if it comes from a random sample, and it doesn't necessarily say that these are from a random sample. Pretty sure. So we don't know if the data come from a random sample. The number. Now it looks like there's 27 data points, and so we'll have to look at the distribution. And so I plotted the differences of these in my L3, and I got something that looks like this. It's pretty symmetric, and so since that's pretty symmetric, uh, we can use a normal distribution because the differences are symmetric. Now finally, independence. They don't really come from a random sample. This isn't an experiment. So let's say assume each data, each commodity is independent. All right. So now let's go to calculations. So if I take my stats on this this value, this is a 90% confidence interval. The mean of my L3 is calculating was 5.33. Oh, and we got to say what interval. So we are taking a t interval. We could say one sample t interval if we wanted, but we don't necessarily need to. And so this was 5.3 repeating, plus or minus, plus or minus our margin of error. This one I should probably just do by hand. So, um, so that's plus or minus our t star, and that's our s over the square root of n. So our s in this situation is 5.23. Oh, and I just did that, just doing finding it on my calculator. And that was, my n was 27, and now we have to look for our t star. You look at the n is 27, we go back to 26, you go to 90% confidence interval, and that's 1.706. And now we just have to figure out the values. I found 1.717. So I take 5.33 plus that answer. I get 7.04. And 5.33 minus to get 3.613. So that's our interval. So we are 90% confident that the amount of vitamin C destroyed for uh, all of this commodity is between 3.613 and 7.04. All right, hopefully you can do your on your own.